Greetings, my name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 5 on integration and segment 5.3 on integrating the exponential function. We have two rules for integrating the exponential function. Our first rule says that if you want to integrate e to the x dx, the integral yields the function itself, e to the x plus c. Our second rule says that if this exponent is a function of x, so you have e raised to the f of x, and you want to integrate this, you must have the derivative of the function in the problem. This goes along with the chain rule that we discussed in the previous segment. And when you have the derivative of this function, you can integrate and you get e to the f of x power plus c. So let's look at some examples. Suppose that I wanted to integrate 5e to the x minus 1 with respect to x. Well, according to the rule that we just established, the 5, we can move across the integral sign, we hang on to it, and the integral of e to the x is e to the x. And then one of our basic rules says that if we integrate a constant minus 1, we get minus 1x. So we don't need to show the coefficient of 1, so my final answer, 5e to the x minus x plus c. In my second example, the exponent is 4x plus 1. So according to the rule that we just established, in order to integrate e to the 4x plus 1, we would have to have a 4 present in the problem. You can put the 4 here, or I'm going to slip it in right here out front. Well, if I put that 4 in, then I need to accommodate for that 4 by multiplying out front of the integral sign by 1/4. So my final answer would be, hang on to the 1/4, and then I have everything I need here to integrate, e to a power, and then I have the derivative of that power, so I get e to the 4x plus 1 plus c. Or if you prefer, you can write this as e to the 4x plus 1 divided by 4 plus c. Let's look at a couple more examples. In the first example, notice that I have e raised to the x to the third plus 3x squared power. And the derivative of x to the third plus 3x squared is 3x squared plus 6x. So I have exactly what I need to proceed with this integration, and so my answer would be e to this power, x to the third plus 3x squared. And I'm done. In the second situation, I have the same function, e to the x to the third plus 3x squared, but I don't quite have the derivative of this function because the problem only gives me x squared plus 2x. But notice that if I insert a factor of 3 in front of the x squared plus 2x, that would give me 3x squared plus 6x, which is what I need for the derivative of this function. If I insert the 3, I have to accommodate for that with a 1/3 out front. So my final answer would be 1/3 e to the x cubed plus 3x squared power plus c. Or if you want to write that, e to the x to the third plus 3x squared divided by 3 plus c. Well, that's it for this segment. Now you need to practice this concept by working similar problems. Good luck.